Hello Math 1010. This is a video for section 10.4. In this one we are adding and subtracting and continuing with multiplying some radicals or some roots. So in the previous section in 10.3, this is big, this is important. We learned that if you have the square root of a times the square root of b, you can rewrite that as the square root of a times b. However, that does not work with addition. If you take a look at this equation here, this says the square root of a plus the square root of b is not equal to, so that is a not equal sign, not equal to the square root of a plus b. So you cannot bring them inside the same square root if there is addition occurring in between them. So that's big. Let's go ahead and take a look at example 1 then. If we can't do that, what will we be doing in today's lesson? If you take a look at example 1, it says simplify by collecting like radicals. So it's kind of like terms. If you remember, you can combine 2x cubed with 5x cubed because those are like terms because they have the same variable with the same power. So that would be 7x cubed. That's what we got to do with radicals as well. So we have 2 square roots of 3 plus 5 square roots of 3. So that would have to be 7 square roots of 3. Another way you can think about it, remember, when in doubt, write it out. If I have 2 times the square root of 3, that's really the square root of 3 plus the square root of 3. And then if I have 5 times the square root of 3, that is 5 square roots of 3 being added together. So how many total square roots of 3 are being added? 1, 2, 3, 4, 5, 6, 7. So we would have 7 times the square root of 3. So again, using that principle of when in doubt, write it out. Let's take a look at the next one. We notice that we have 10 root 2, subtract 4 root 2. So if this is like terms, then we would have 10 minus 4, which is 6, and then the root 2 stays the same. If you look at letter C, we've got square root of 5 plus square root of 3. Those are not the same roots. Like they're both square roots, but they don't have the same number inside. So those would not be like radicals or like roots. So that would just be, you can't combine those any further. You just have to keep it like square root of 5 plus square root of 3, or you could just say cannot combine further. Sometimes it won't be so obvious if the roots are like or not, if they can be combined. So you may have to do some simplifying. So if we take a look at example 2, we could simplify these like we did in 10.3, but if you put them in your calculator, it would be 2 square roots of 5 plus 6 square roots of 5. So originally it looked like we wouldn't be able to combine them because it's 20 underneath the square root in the first one and 45 underneath the square root in the second one. But after we simplify, we see that we have like radicals with the square roots. So square root of 5 and square root of 5. So that would be 8 times the square root of 5. The next one, we've got some variables with it now, so it's going to be a little bit more work. So we've got the cube root of 8 is 2, and then the cube root of y to the 5th, well, 3 of the y's on y to the 5th will cancel completely with the cube root, or not necessarily like cancel, but leave you with 1 y, and then you would have 2 y's left over. Not the 5th root, but the 3rd root. You'd have 2 y's left over from the 5. And then if you look at the next one, cube root of 27, that's a nice root. That would be 3. And then same thing, you would have 1y come out. So what's going on here is we've got the cube root of y to the 5th. That's the same thing as the cube root of y to the 3rd times the cube root of y to the 2nd, if you remember that from last lesson. So then we still have the cube root of y squared. And now, if you look at that, we actually do have like radicals. We have the cube root of y squared and the cube root of y squared. So we can subtract these, and we can say that 2y cube root of y squared minus 3y cube root of y squared would give you negative, technically 1, but we don't need to write it because it's being multiplied. But negative 1 y cube root of y squared for our final answer. That one's a little tricky. Go ahead and pause the video and see if you can do practice A. All right, so on practice A, we've got 5 times the square root of 25, but hold on, square root of 25 is just 5. So let's write that as 5 times 5, and then minus 10, and then plus root 5. So 5 times 5 is 25, minus 10 plus square root 5. There aren't any roots besides just that root 5, so 25 minus 10 would be 15, plus the square root of 5. So that would be our final answer on the first one. If you take a look at the next one, we can split this division up, so it's the cube root of 5x divided by the cube root of 27. The reason we want to do that is because cube root of 27 is a perfect cube, so that would be 3. So we would have cube root of 5x over 3 plus 4 cube root of 5x. And if you take a look at that, the roots are the same now. We've got 1/3 cube root of 5x. So we've got 1/3 times the cube root of 5x plus 4 times the cube root of 5x. So we can just add the 1/3 and the 4, and we would get 13/3. So then this can be rewritten as, for a final result of 13 cube root, let's see, 13 cube root of 5x, all being divided by 3. Okay, let's go ahead and go to the next page. The next one is going to be combining multiplication and addition and subtraction. So if you take a look at example 3, just by looking at it, I bet you'd be able to decide what to do. We've got some parentheses there. Let's go ahead and get rid of the parentheses by distributing through the square root of 3. So that would be square root of 3 times square root of 3 minus square root of 3 times square root of 2. So square root of 3 times 3 would be square root of 9 minus square root of 3 times 2, which would be 6. And then square root of 9 is nice, that's just 3. And then left with square root of 6, which does not really simplify any further. If you look at the next one, this is going to get a little crazy. we're going to distribute the 7 root x through, and then we're going to distribute the 5 through. So let's do the 7 root x first. So that would be 21 root x times root x minus 7 root x times root 5, if you're seeing that. And then underneath, I'm going to kind of try to line up my like terms. So plus 15, oh, let's see, those are not like terms, JK. Yeah, let's just keep going. They won't line up perfectly, but let's do plus 15 root x and then minus 5 root 5. So this one's actually kind of interesting because none of these are like roots. This is root 5, this is root x, this is root x times 5 when I put those inside one root. And then actually, this does simplify. It'll be just x, because that's root x squared, but doesn't combine with anything. So we've got a final answer of 21x, because root x times root x is just x, and then minus 7 root 5x. I'm putting them inside the same root, and then just writing the 5 first. It just kind of convention looks a little better. And then plus 15 root x, and then minus 5 root 5. So that would be our final answer on that one. Okay, if you look at this next one, you guys know that because of the subtraction in there, we need to rewrite this twice. And then we'll distribute through the root x, and we'll distribute through the negative 3. So we'll get, let's see, let's kind of separate this a little bit. Okay. We will get root x times root x minus 3 root x, and then minus 3 root x, so those will be able to be combined, and then plus 9, negative 3 times negative 3. Okay, so root x times root x, that's root x squared, which will simplify, and then minus 6 root x, because those are like radicals, and then plus 9. So let's simplify that root x squared to just x, and then minus 6 root x plus 9. And that would be the result on that one. All right, go ahead and pause the video and see if you can get practice B. Okay, so on practice B, when we distribute through the root 3, we'll have 5 root 3 plus root 90, because those are being multiplied, so we can do 3 times 30. And then this will just be 5 root 3 plus, and then this simplifies to 3 root 10, and those can't be combined any further, so that would be our answer on that one. And then the next one, we'll distribute through the root 2x, and we'll distribute through the negative 5. So we'll get root 2x times root 2x plus 5 root 2x, and then minus 5 root 2x, and then minus 25. And these actually do have some things that can be combined. So if we take a look at this, root 2x times root 2x, that's the same thing as root 2x squared. So the root and the power of 2 are going to undo each other. And then 5 root 2x minus 5 root 2x would be 0 root 2x. So those just add up to 0. They cancel out completely. And then we still have the minus 25. So our final result would be 2x minus 25 for this one. And then on this one, you wrote it out twice. So it was root x plus y times root x plus y. And then you distribute it through, and you got root x squared plus y root x plus y root x plus y squared. And for a final answer of x plus 2y root x, and then plus y squared. And that is our final result. And that is section 10.4.